Okay, so I realized after like I said, I assigned that homework. And then I realized there was one concept that I must have just left off. Or originally had planned to do it in a different place. But what I need you to do on page 15, hopefully you haven't doodled all over page 15. Can you make another box at the bottom? There's one more concept that we needed. So I just extended those lines, so we made one more box. Does anybody need, did anybody use that space up or anything? Cam, you wrote hay all over it? Yeah, do you want like a Post-it note to put in there? Okay. All right. No, I don't even know if I have them anymore. Just take my regular hall pass. It should be fine. I don't see it anywhere. I don't know where it disappeared to. Yeah, just take that. Yeah, do you want another one? Like. Anybody else need some Post-it notes to make some blank space at the bottom? All right, here's what this box is going to be. The word is unconformity. I can only fit it if I go diagonally. So it's unconformity. So UNCONFORMITY. Unconformity. So an unconformity, the definition of an unconformity is a buried erosional surface. That's going to be the first line. So it's a buried erosional surface. But we do need to put one more bullet in there. So it's going to be a 2-bullet box. So an unconformity is a buried erosional surface. Before we go any farther, I kind of want to talk about what it is before we get the second bullet and a drawing. So we've already discussed how these layers form, how the strata that we were drawing yesterday, how they form. So it first started when sediments got deposited, buried, compacted together, and you got your oldest layer laid down first. Then we talked about how after a few million years, more sediments might get deposited on top of that, squished together, and you might have a new layer on top. And then that just keeps happening and happening over and over again. But one thing that we didn't talk about that I think you guys brought up, but I didn't really address, when this pink layer is sitting here for a while, what's some things that might happen to this pink layer after it's just been sitting here, hanging out for a little bit? It could erode. A glacier could come through. A river could come through. Or it could be a really windy situation and doom, that layer flies off. So there might be a layer that has been removed from erosion. Now, will there be any evidence that erosion happened? What might be left behind? Guys, stay with me. What might be left behind when this layer is eroded away? In real life, not necessarily Plato life. What evidence is there that erosion happened to the land? Oh, this was all last chapter. Guys, what will a glacier leave behind after it goes through? Scratches, U-shaped valleys, moraines, things like that. What might a river leave behind? Which shape? V-shaped valleys. There is always going to be evidence that erosion happened. For me, remember it was a pink layer. So in this case, if this pink layer got eroded away, it might leave behind a few pink pieces. There might be some evidence that that was there. But then what's going to happen on top of that is new sediments are going to be laid down and we're going to end up with a new layer. What happened to all the stuff that was in this pink layer that got eroded away? It moved. It's gone. What happened if aliens landed on Earth and left behind their spaceship in this pink layer, but then that pink layer was eroded away? What else is eroded away? The spaceship's gone. Then when scientists come and they dig up the rocks, will they ever find that spaceship in this area? No. So will they ever know an alien landed here and left behind a spaceship? No. So what that's called is an unconformity. Here's my best analogy to it. Let's imagine the only way you were able to learn history was you were given a book. And they say, here, read this and learn about history. But you're flipping through and you realize that chapter 56 is missing. It's World War II, by the way. So if that whole chapter was missing, would you know about World War II if this is the only way you got to read about or learn about history? That's what an unconformity is. An unconformity is an area of the rock record or the rock history gets ripped out and thrown away. What it means is there's going to be a gap in your book. There's going to be a gap in what you understand if this is the only way you get to learn about history. So an unconformity, that layer gets eroded away, moved down the road, but what it leaves behind is a gap in the geological record. So that's what goes in the second bullet. It's going to be a gap in the geological record. It's like a missing chapter. Whatever happened in that chapter, so I mean, I know I made up a goofy story about aliens, but it doesn't have to be aliens, it can just be a fossil. We might not know what lived in an area because that rock record got moved away. So it doesn't have to be an alien, it could just be a fish fossil. We might never know that there was an ocean there because that rock layer got moved away. How this is shown on the regents. So again, what we're going to do is we're going to start with our rock layers. So I'm going to have one layer and I'm going to shade it in. I'm going to have my next layer, that's going to be blank. The regent, now my next layer should be a shaded in layer, but that's going to be the one that's eroded away. So that's shown with a dark, and I don't know if you can make your line a little bit darker than the rest of them. It's shown with a dark squiggly line. And then your next layer. And then the next layer on top of that. So that's how they show an unconformity. It's a squiggly line. So it is evidence, just like I said, there would be like striations or a U-shaped or a V-shaped valley or a moraine might be left behind. And that's what they're trying to represent with that squiggly line. They're trying to represent, okay, we know erosion happened, because there's evidence erosion happened, but we don't know what was removed. So that's an unconformity. So now that you kind of understand the concepts of original horizontality and principle of superposition, we're going to take this to the next level. And we're going to kind of talk about how scientists put together a full history of an area. So hopefully you guys grab 6 colored pencils. Like I said, you can share your colored pencils among the people around you. So not everybody needs 6. We're going to actually go to page 19, but before we go to 19, turn to page 21. And what I need you to do is gently remove page 21. So if that just means ripping off the corner, we're going to be completely destroying this. So then once you rip that out, we're going to go back to page 19, which you should notice the top of page 19 is the same exact picture you just ripped out on page 21. What happened? What did you do? Go ahead and just gently rip them out.
Oh.
Oh, anybody else need their packet reconstructed?
Hey.
Yeah, only one. All right, so like I was saying, the top of page 19 should look just like page 21 that you ripped out. It looks like this. What this is called an outcrop. So an outcrop is a word we're going to define it tomorrow in our notes officially, but an outcrop is just an area of exposed bedrock. It's a place where the solid rock is not covered up by dirt or grass or anything. It's just exposed. Can you guys think of any place you've seen solid rock exposed at the surface, not covered by dirt? Yeah, do you think of one? The Grand Canyon is literally the best example I could ever think of for an outcrop. So the Grand Canyon is just a bunch of solid rock that's just exposed. There's no grass, there's no dirt, there's nothing on top of it. You can see down into the canyon and you can see some of the other layers. Do you guys think of anywhere around here that you might have seen that? Because not all of us have been to the Grand Canyon. Huh? Where specifically were you hiking? What'd you say? Oh, you never been to the Grand Canyon. The Eternal Flame. If you guys have ever been down to the Eternal Flame in Chestnut Ridge, when you're walking down by the creek, that creek you're walking in is an outcrop. When you get to the Eternal Flame, that waterfall is an outcrop. But not even anything like that is fancy. Have you ever walked in a creek around here? If you've ever seen where the walls of the creek are just stones or rocks, even down under that bridge that I love to talk about between Class Boys and Tim Hortons, when you go down there, you can see that the walls of that, it's not none of us would call it a canyon, but maybe in a couple million years, maybe it will be a canyon. And that will start to look where you can see the different layers of rocks on the outside. Letchworth, another perfect example where you can see rocks exposed at the surface. Even as simple as driving on the thruway or the 219, there are some places where there's hills on both sides. It's down closer near Hamburg. So if you're going from Springville towards Buffalo on the 219 by Hamburg, there's places where they clearly blasted through a hill to put the road there. And you can see the walls of the 219 there are solid rocks and you can see the layers. So that's an outcrop. It's just a place where you can see the rock layers. So this is supposed to be like that, where you can see the rock layers on the side of the wall. But what do you notice about this particular outcrop that I have up on the screen? It's slanted. Do you guys remember we drew a picture that looked like that? What is that slant representing? That line going down? We did do it yesterday. It's a fault. It's a place where the rock layers got broken. So this line is representing a place where the rock layers got broken. Now what the Regents is going to do is they're going to say, hey kids, can you put these rock layers in order from oldest to youngest?
Yeah.
You should be able to, right? What did we learn yesterday to put them in order from oldest to youngest? Youngest at the top, oldest at the bottom. Do we see a problem?
Yeah.
What's the problem, Dakota?
They're not.
They're not the same thing. Because of that fault, so what happened is that break caused the rock layers to shift, and we have two different layers on the bottom. Now, I'm sure there are some of you who can just look at this and use your imagination and rearrange them. But what fun is that? We don't get to color if we just do it quickly like that. So let's take a moment. So yesterday we played with Play-Doh, and today we're going to color. So please get back to your roots and enjoy some time doing mind unstimulating. I don't know what that's called, but let's just relax and play with Play-Doh yesterday and color today, okay? Can you learn while you color? Maybe. All right. What I'm going to have you do is because I do not have much of imagination. I cannot visualize anything. When they were redoing my kitchen, the interior designer kept saying, well, can you picture this? I'm like, no, I have no idea what you're talking about. So maybe it's me, but I'm going to force you all to be like me today. And we're going to not use our imaginations. Nick, ice. What I'd like you to do is grab a colored pencil. I don't care what color. I believe I picked green first, but you don't have to follow my. No, I guess I went with red first. I went and I colored this thing going up the middle. Who remembers from yesterday what this caterpillar looking thing with whiskers on it is called? Did you say not you? Thank you very much. What? It is magma, it's representing magma. What's it called though? And so is this an intrusion or an extrusion? How do you know it's an intrusion? Okay, wait, say it again. Because it doesn't go out. That's part of the reason you know it's an intrusion. But we talked about yesterday how the layers on top of it may have been deposited after the lava had cooled and hardened. How do I know that's not the case here? How do I know that this really was never on the outside? Right, guys, remember how I talked about those little whisker things? So these little whiskers, which are called officially contact metamorphism. Remember, that's a lot like when I like to think of it as hot lava is burning the rocks around it. So an intrusion is going to be completely covered in whiskers. So this is an intrusion. And again, what do you notice about the intrusion on either side of that line? It doesn't match up because it got broken. So what we have to figure out is when did that happen? So actually, can you guys answer, did the break or the fault happen before or after the intrusion? Okay, so I actually heard some like attitude with that answer. Why are you guys answering me like, of course it was after? How can you explain, Alex? That's where I was hearing the attitude from. How do you know that it came after? What was your dead giveaway that it came after? The fault came after. Because the intrusion got moved. Guys, can you break something that's not there? No, you cannot break something that's not there. So that fault, that intrusion had to be there to get broken. So I need you guys to keep that in mind. You always have to have the rock there to be broken. So the rock is older than the break. So now I just went through and I colored the layers. You guys can go ahead and pick your colors. You can pick whatever colors. We're just color coding this. So I just went ahead and put my finished one up on the board for those of you who are colored. No, I'm sorry, we're coloring the big one. Color the big one. What? Yeah. Color the big one. Some of you might want a seventh color because I think I left the one down at the bottom blank. And I think some of you are coloring them, so you just might need to grab a seventh color, which is not a big deal. hate to rush you, but I do need you to go just a smidgen fast, like if you're less than halfway. Speed it up. DJ. What?
Or on the bottom right, is that like a?
It's actually white. So if you're finished coloring, the next step is going to be to cut out the little picture you just colored. So, huh? The key's just gonna go right in the garbage because we're gonna use the key that's on page 19. Because it is the same key. So I started off by just cutting it out. Oops, I'm sorry. Cutting it out into the square first. It is, you don't have to match up, whatever floats your boat. What I started off with is, taking the scissors and cutting it out into just the little square that you colored. The key can go into the garbage because we have a key on the top, page 19. I forgot I need tape. Oh, not yet.
No. One's blue. Because we're not done yet. You'll see why. All right, the last step, so hopefully you've got this cut out. The last step is we need to break that break. We're basically putting this back together. So what I want you to do is take your scissors and cut the fault. So you end up with two separate sections. So here you go. Here's how it is colored. Yeah, I've never claimed my scissors are very strong, but yes, they can cut rocks apparently. And then we're gonna go ahead and put this back together the way it was originally. And unfortunately, one thing you're gonna find out is that that layer, that polka dot layer is a little skinny. Not sure what happened there. Go ahead and line it up as best you can. I know it doesn't line up perfectly. You can either choose to line up. Why don't you go ahead and line up the intrusion? So if you line up the intrusion, everything else will kind of line up perfectly. They don't line up, awesome. And then you can go ahead and use that tape that I stuck somewhere on your desk to tape the back. And now you don't have to use your imagination. I know, right? Now you can see which layer is truly the oldest. Which one is it, by the way? Use the key. Conglomerate, that one with the bubbles in it on the bottom, is the oldest. So of course it can't be that simple though. There's another step the Regents is going to have you do. And that step is to put them in order, the events in order of how they happen to form this area. The first thing though, that I'm going to need you to do, because I know I screwed up, see how that top box on page 19 is slightly fatter than the rest of the boxes? I don't know where my line went, but can you go ahead and divide that top box into 2 boxes? So just, yeah, I screwed up. So again, all I'm asking you is this top box, go ahead and divide that up into 2, because for some reason, either I hit enter or didn't hit enter. I'm not sure what happened, but my box is not the right size. So we're going to be told the directions for these will be to place events in order in which they happened. In order in which they happened will be the stupid directions the Regents is going to use. I think they could say it a lot more simple. But what does it mean? Place them in order in which they happened. What's going first, the oldest or the youngest? Oldest. So we're going to label this oldest here. And then at the bottom is going to be the youngest. And we need to go through these rock layers. And first tell me, the first part is going to be the event, the rock, the name of the rock, or the event. So some events that could happen would be the fault or the fold or a tilt that happened. So in this one, we only have a fault, a break. So we do have to put that in there as well. So let's go through. When doing this, it is always important to look to see which one is at the bottom. That will be the oldest. But before you get too far into it, you do need to decide, well, when did the intrusion happen? When did the fault happen? So let's go through. Can I borrow? I'm going to borrow yours, Riley, because yours is right here. So which one did we decide is the oldest? Conglomerate is the one at the bottom. I know it's conglomerate because I use the key right here and it's conglomerate. By the way, will you need a key on the Regents? Where do they have rock types listed? Not the back, it is on the reference table, but it's not the back. It's, yeah, pages 7. So remember, so again, that's where they got this from. So that is there if they don't ever give you a key. So the oldest rock is going to be conglomerate. What's the next rock? Shale. Then
Sandstone. Then. Yes, notice that siltstone and shale are slightly different. Be careful with those. Siltstone has the dots. Shale is just dashes. Then what happened? Then. Good. RECIA. Then what? Then. So I did hear contact metamorphism. It's always going to be the intrusion / contact metamorphism. They happen at the same time. So when there is a little bit of, or when there's an intrusion, the contact metamorphism comes with it. Now we have one line left. Is there anything else that happened to this? The break is the fault. What's the last thing that has happened to this set of rock layers? Nope, is the contact metamorphism. Notice the squiggly line on top? That's going to be erosion. So for now, that's all I want you to be able to do is put them in order. Now, homework, we're going to redo page 17, which some of you already did, but now I'm going to add 18 onto that. So your homework is pages 17 and 18. I think there was 8 questions, or is there only 7? Okay. So go ahead and actually put some effort into those 7 questions. It shouldn't take you more than 10 minutes. And also remember, today is the last day to do your test corrections.